All right, so I know that you learned to solve rational equations in Math 3, and we are just going to review that because we will have some rational equations come up in our log unit and a couple other places that you'll need to be able to solve. And what makes it a rational equation is that we have a fraction with an x on the bottom in at least one term. And the goal is to kind of get rid of the denominator as soon as you can so that you're just dealing with like a linear equation or a quadratic equation. So when you have a rational equation, the first thing you want to do is factor any of the denominators that you can. Sometimes you'll be able to factor a lot of them, sometimes just one. Maybe you can't even factor anything sometimes. You can factor this one. It has a GCF of x. So I'm going to rewrite the equation. These usually take up a lot of paper just because it's better to show your work and not get kind of lost in what you're doing. So I'm going to factor the denominator like we said, which is factor out a GCF of x, and I'm left with x minus 2. All right, and then what you want to do next is find, and some people call it different things. I've heard it called the least common multiple, the least common denominator. Basically, you're looking at your denominators right now, which are x minus 2, 1, and x times x minus 2. And it's kind of like you're thinking, how could I get a common denominator for all three of these terms? Well, I would have to have an x minus 2 because I see that. I would also have to have an x. So you want to find your least common denominator. So in this case, again, it's that I need an x and an x minus 2. Now I don't need two x minus 2s because that's just part of the denominator that I'm going to make. Now, I don't actually get the denominator for each one. What I do, and it's kind of up to you at this point. This is what you typically see in like the explanations too, so that's why I'm going to stick with it, is you multiply every term by your least common denominator. And in doing that, it gets rid of your denominator automatically. So you would multiply every single term by x and x minus 2. And the reason for that is, look at this first term. X minus 2 is on top and the bottom, so I'm not actually going to multiply it by it. What it did is it got rid of my denominator. And so the only thing I actually have to multiply is 1 times x for this first term. And no more denominator. So that one's no longer a fraction. This one wasn't a fraction to begin with, so I will actually have to multiply. So plus 9 times x minus 2. So I'm actually going to have to multiply that out in a minute. Bring down your equals. You don't want to ever lose your equals. And then this time, x and x minus 2 canceled, so we are left with 2. So in that step of multiplying by your least common denominator, you should get rid of your fraction. There should be no more fractions left if you did that correctly. And now it should be like a Math 2 problem, solving a quadratic at most. So 1x plus 9x squared minus 18x is equal to 2. For quadratics, you always get them set equal to 0. And then solve your quadratic. A lot of times these factor. This problem included, it factors. Let's see, 9x and 1x maybe, and then, yep, 2 and 1. And then solve each factor for x. All right, these are your solutions, but remember that last you have to check for extraneous solutions. And extraneous solutions are solutions that we solved for and we got, but when I plug them back in, they're not in the domain. Basically, they don't work. And you always plug these back into the original. All right, some people teach that you actually plug it in to the entire equation, and if you prefer to do that, it's okay. I think it's time consuming. Extraneous solutions, like I said, they come from not being in the domain. So for rationals, you really only have to plug into the denominator and make sure that it doesn't make the denominator 0. Okay, if it makes any of the denominators equal 0, it's extraneous. So like 2 minus 2 is 0. So 2 is extraneous. All right, -1/9 is not going to make this 0, and it doesn't make this 0 either when you plug it in. So -1/9 works. Now, if you like to make sure your answer was right, maybe that you didn't make any mistakes, then yes, you could go back and plug it into the left-hand side in the calculator, plug it into the right-hand side and make sure they're equal. But if you're just checking for extraneous, plug it into the denominator, make sure it doesn't make the denominator equal 0. And if it does, then it's extraneous, like 2 was for us. Okay. So with this, I think I assigned the Delta Math again, and the reason I like that is they just give really good explanations that look very similar to this. Rational equations, if you are struggling on it, then please reach out to sign up for tutoring, and we can work through a lot more. I just wanted to make sure that we went over, a lot of times going over like one, if it's something you knew how to do in Math 3, it reminds you, and a lot of people can go from there. But if not, please reach out. We can work on through tutoring, we can work through some more of these. Okay, don't struggle on your own. We can work through some more.